Good morning to everyone. Today we are going to have here an invited talk from Joaquín Matres. He is like a veteran chip designer. He has been involved in companies like Intel, Hewlett-Packard, PsiQuantum, or Google X, and he founded GDS Factory in 2019. It has like more than 3 million downloads, and today he's going to talk about this GDS Factory Plus, how we are able to do the designs, and he's going also to explain a bit about do data. So thanks, Joaquín, for coming from the States, and the floor is yours.
Thank you, Joaquín. Hi, everybody. How many of you have used GDS Factory? Okay, thanks. No? Yeah, so we basically are a team of industry veterans that we work in many companies. And in a lot of the companies that we work for, we identify some needs doing the chip design. And one of the problems we found is that tools were very hard to use for drawing photonic circuits. And there was also, you needed many different tools to do different things. So we started GDS Factory as an open source project. And since then, we have achieved, we are reaching 3 million downloads, almost 100 developers, and we have over 500K downloads in the last 5 months. One thing that we wanted to do with GDS Factory is that we wanted to do one software to do all your chip design needs. If you compare to other software, it's much easier to use because it works on Windows, Linux, and Mac. And it also allows you to do all the way from like accessing the Foundry PDK, schematic, layout, device level, circuit level simulation, as well as data analysis. I will show a demo of the tool so you guys can see. But yeah, we support over 25 PDKs. We have your logo here too. Like you see this 10mm, it's here on the side. So this is also one of the PDKs that we support. And the tool is built on top of VS Code. So you will see they have like basically an editor, schematic editor, like 3D beware, layout beware, as well as the verification for DRC and LVS. And we have a company now to support it. So we also provide the tool itself, as well as extra services. Like for example, a lot of companies come to us to help so we help them make a PDK, like a library of components. And we also help companies like doing quantum or visible, like different wavelengths. So we help them build PDKs as well. Yeah, and we support more than, it's 200 times faster than other tools. We support 25 foundries, and we also have integration with more than 20 tools. We also, as we were doing chips, we also realized that there were not really good tools to store and analyze the data. So a lot of times there's data like schematics, there's simulations, there's layout, there's the DRC, and there's the yield data. So we wanted to store all that data into one place. So we made a software that allows you to track the data through different sources and visualize them. And you can do this through the graphical user interface or through Python. And yeah, it will allow you to do device level, die level, wafer level, or lot. And yeah, to summarize, GDS Factory Plus for design and verification, and then we have the data for validation. And we have another tool for like mask biasing, like if you guys do OPC, a lot of times when you do like devices, the fabrication has a bias versus the target. So we have a software that can help you calibrate this. And yeah, just to give you an idea, it's roughly like 9,700 per user per year. For like research centers or academic institutions, we offer like the same price for the whole like research center. So it will be like, if you guys want to get the GDS Factory Plus, it will be like 9,700 for the whole research center. So you can also use it for teaching as well as for research. And I wanted to show a demo. Like I have here an example of like a filter. Like the app works on VS Code, and if you guys want to try, we can also I can also spend some time today with you setting up on your computer. But you don't need to install anything. You only need VS Code, and then you need the GDS Factory Plus extension inside VS Code. And then there will be 3 buttons that appear here. One is for the PDK, one is for the DRC, and the other one is for the ChatGPT. This is for AI integration. So you can ask ChatGPT to draw the circle for you. There are 2 main parts. So there's like for example, here's the project components, and we also have foundry components. So this is, for example, a cornerstone PDK, which is open access. And this allows you to like visualize, like you can see the top view, or you can also, if you do show 3D, you can also visualize the 3D of the chip. So yeah, this is kind of like a. Another thing you can also do is that you can do, like for example, like a lattice filter. You can see the schematic, and then you can see the layout, and see this, and then you can see. When I'm doing in the schematic, I can simulate the circuit. So this allows me to simulate the schematic directly, and I can change the parameters. For example, like I can change this Mach Zehnder. I can change it from 20 from 100 micron delta length to 20, and if I save it, automatically updates. And I can run the simulation again, and it will show like the spectrum has changed. So this is a filter in RF that basically filters in 2 stages. Another thing we can do is we can do like device level simulation. So we have these examples here, like how to do, like we were talking before about a heater design. So you can take an arbitrary component like a thermal heater. This is a tinite heater that, as you can see it in 3D. So you can see there's a waveguide here, and there's a heater on top. And I can mesh it. So I don't know if you see here, but I have a 2 micron heater here, and waveguide is here. It's like a 0.5 micron waveguide under the heater. And as I apply different currents, I can see the thermo-optic coefficient of the heater will change the refractive index of the light traveling. So you can change for like 7 milliamps of current, I can get like 5 radians of phase shift. And I don't know if you notice here, but the waveguide is like this little square here. If I want to make it more efficient, I can make because a lot of heat is actually going in the wrong direction, so I can make the heater a little bit thinner to reduce the wasted heat that goes somewhere else. So I can make this width of the heater, like make it thinner, like from 2 microns to 1 micron. I don't know if you see here, now the thinner is narrower. And I can sweep again, and I get more than double the phase shift. I also have an animation if you guys want to see. Yeah, we have also, you can do time domain simulations. Like if you want to see the response of the heater when you apply the heat, how long does it take to make the phase change? So yeah, let me see if maybe it's a bit slow. The other thing that it allows you to do, like we can also do a circuit together. So let's define, like when you create a component, you can create a component from your foundry components, from your project components, or you can define your own custom component in Python. Like for example, we can define like something like a parametric cell. Like let's just do this hello world. So I could change here like the text, and then I will see the change here. So it's a very easy way for you to define your building blocks in Python. And the nice thing of this is that it will basically, if you have any error, like when you're doing this, like let's say you have a typo, it will automatically turn red, this component. So as you're making a chip, a lot of times you're working in a team, and someone creates sometimes mistakes or errors. So it's nice to be able to catch them as soon as possible. I'm thinking I'm speaking English, but is it better that I talk in Spanish, or is I don't know. Most people speaking. I can keep in English. I don't know. I didn't ask in the beginning. ¿Preferís español o en inglés? Okay, in Spanglish. See, if someone prefers in English, maybe they say something. English speaking? Okay, yeah, so maybe keep English then. So if you have the any error, you can actually click here and it will tell you the error. And if you fix the error, it will show you back to green as soon as you fix it. So this allows you to do like things like packing. It's very easy to do it in Python. Define like a grid of components. So all these are examples for you to get started with the tool. Like we have a lot of people who are starting to use GDS Factory for the first time. So we have examples how to do like drawing circuits, like routing. All these things are very important. But the part I wanted to show is how when you create a new component, like how it will look like. So I can create a new schematic and I can call it, for example, ring filter demo. And this allows me to, I can create here an instance that could be like a ring. And I can add a second instance here for a second ring. And this allows me to see, like for example, I have two rings now here. So what I'm drawing in the schematic, I also see it in the layout. And then I can define a route from one component to another component. And this defines an automatic route. And because the route is basically automatic, even if I modify the placement of the ring, the route will follow. And this is because they are linked in the schematic. So I define, I'm going to auto route from this ring to this ring. And even if I modify the placement of the second ring, the route will follow. Another thing I can do is I can also define like input and output port. So I can call the input port O1 and I can define an output port O2. And I can link this, define a logical link from here to here. Sorry. Yeah, sorry. Let me catch this. I think it's a logical link. Yeah, so I can, I can also define a route from here to here. Yeah, so I can define this. I can look at the port. Yeah, I mean, I have another one here that has the ports. So what I can do now that I have the two rings, I can actually simulate the frequency response of these rings. And another thing I can also do is I can also verify that the circuit is correct. I don't know how many of you running DRC. Do you run DRC too? Yeah, so when you run DRC, you want to be able to see any errors that you have. So if I click here DRC, I can check the DRC. And this will allow me to see any errors that make the chip not being able to manufacture it. And the DRC, when it's finished, it will show it to the DRC menu and it will show you the errors. So you can actually highlight how many errors. So you have 4 errors of minimum space and I can go through each of their individually. And I can even look at the code at the same time as I look at the error, so I can actually fix them. So I can increase the spacing from 0.2 to 0.3, and now I see that the marker are not relevant anymore because I already fixed the errors. Yeah, so any questions so far? I mean, all these things are actually recorded. For example, if I go to gdsfactory.com, we have all these GDS Factory Plus videos that will show you all the benefits of the GDS Factory Plus. But we also have the documentation here for the open source project, which is GDS Factory. And then we have the data management project as well here, which is also shown. Put this at the bottom. So yeah, this is also another interesting, I think, Joaquín, you were asking about this. So we have videos of all the features of do data as well. And we have also some PDKs for we have the Skywater 130 and the GF 180 for electronics. So, and for MEMS is very similar to photonics, where you want to basically see the 3D structure. And we have the heat, charge. So we have the multi-physics solvers also built in. So this allows you to also design MEMS. I don't know if you say, some people here maybe also doing MEMS. Yeah, the nice thing of this is the way I see it is that when I was doing chips 15 years ago, like I needed to install like many different tools. So you needed to have numerical for simulation, then you needed to have a cadence or synopsis for layout, but they're pretty slow and pretty hard to use. And then you have to buy caliber for DRC. So you have to have like 3 different software, and they're all very expensive, and they all work only on Linux, and it's a bit kind of like very hard to do your work because there's no an easy workflow. So this is how I design, this is how I run DRC, this is how I put my measurements and simulations in one place, and this is how I analyze it. So something we built is a unified software to do all these parts in one place. We still interface with like numerical and all the popular software, but you don't have to use them. We have alternatives for all of those. And in a lot of times, the alternatives that we have are much more powerful because they can run faster, we can scale to many more simulations. And yeah, this will allow you to do like advanced research without being limited by what the tool vendor provides. And this is thanks to having this open core model where we give the engine for free and we develop the engine with universities. And then we can also, we build the usability on top. So all the UX is only available in the Plus. But yeah, it's all built on top of VS Code. So if you guys use like all these AI tools that are now built on top of VS Code, you can also still use them. And yeah, if you want to check out, we also have this kind of like the same thing I was drawing before. You can do, I can also do them through the AI. So I can ask, yeah, ChatGPT to draw the circuit for us. Well, yeah, it's here. Yeah, I'm just asking 2 rings with a route. You can also ask 100 rings or whatever you want, and it will give you the code. And then you can actually see the GDS. So yeah, this is AI generated. We've been developing with universities. So I have another presentation. So we've been developing also AI tools with a university like in Germany, like Max Planck Institute. And this is something that I think it helps you. I can maybe show the demo if you want to see. So a lot of times when you're doing chip design, you want to do the same things over and over again. So we allow you to create templates. Like for example, this is a template for a transceiver. A transceiver is something that you divide into multiple wavelengths, and every wavelength has different data. So yeah, it has been trained on typical photonic examples. And this is something that if you start having a lot of applications on visible, you could train it here. And then you can choose the wavelengths of the transceiver. If you want to use different wavelengths for every channel, you can select them here. And this understands, okay, I want this wavelength. I need to have something that divides the light into different colors. And every color I will put different information. And they will give you the schematic. So you see the diagram. And then it will give you the netlist. and it will also simulate the circuit. So this is where a lot of the engineering is moving towards, in a way that a lot of AI tools are gonna make your life easier. So you become almost like a manager of the AI tools. And if you are able to like do all this manually, it will take you like maybe an hour or two. But here you can do it in like just a minute. But yeah. So all these things are things that we develop with universities, and like we published a paper on this at the Clio conference in Los Angeles. Yeah. Any questions or? Yeah.
Any questions? Which
The mic, yeah.
Okay, thank you. I had some questions like which are the OS supported? I think.
Yeah, Windows, Linux, and Mac. So it's built on top of VS Code. So if you can install VS Code on your computer, then it works.
Okay, and does the digital design flow it's supported also?
We have some PDK. So the nice thing of this is that we have digital is not supported through us, but I was talking to a student last week. So you can connect it with OpenRoad for digital synthesis or YOSIS. So the only thing that you will need to choose is that if I go back to the PDK, we have these create projects. So you can actually, we provide you with templates for all the PDKs that we support. Let's say you want to do like Skywater or Global Foundries, you choose it here and then you put it whatever you want, and then it will basically load it. I can maybe show you an example of how this looks like. So once you load the PDK, the project components and the foundry components will be customized for that PDK. But for digital, you could use some, I don't know if you heard of Teros HDL. So there's a VS Code extension that allows you to do Verilog code, and then you can synthesize it into GDS as well.
Okay. You said that you have many ways to simulate the things. Which simulators are running under the hood?
Yeah, it depends on the physics that you want to that you are simulating. For example, like in photonics and RF, these are all the simulators that we support. Oh, am I sharing? Maybe it's because it's full screen, or maybe share. Let me share my entire screen. Entire screen share. Maybe there's a bit of a delay. If not, I can say, oh, okay, yeah. So we support many open source and proprietary simulators. The nice thing of this is that the open ones, you can customize them as much as you want, and because all the code is open. And the proprietary ones, you need to work with the vendor. So I don't know if you notice here, when we do, and this is like examples of like Skywater, PDK, capacitors, and this all like standard cell libraries as well.
Okay. And has capability to manage big designs. I mean, GDS with, for example, 1 million standard cells on it.
Yeah, we've done full reticles. We've done like, for example, when I was at Google, we were part of the Skywater and Global Foundries. All those like were very complicated designs that we were able to do with GDS Factory. So it's built on top of KLayout, and that's why it's so fast, because it uses the KLayout C++ library.
Okay.
It's, yeah, even though it's written in Python, we're using the KLayout underneath. Yeah. I don't know, what's your current flow at the moment, like for?
I'm a reverse engineer, so I'm the backwards flow.
Oh, okay, nice.
Really different. But yeah, I use, for example, KLayout. Yeah.
Yeah, it's pretty good. Like to visualize the layouts, and this is what we're actually using here under the hood. Like when I open this, this is actually a KLayout inside. Okay. And you can see it renders pretty fast, and I can also turn it into a 3D.
Works pretty well. Yeah. Okay, thank you. Thank you very much.
Marcel, you have a question?
I was just thinking on if you can explain a bit the difference between the open source GDS Factory and the GDS Factory Plus.
Yeah, that's a good question. Yeah, the big, yeah, that's the most question we get the most. So you can think of GDS Factory open source as a layout generator. So it's very good at creating layouts. But then if you want to optimize the circuit or simulate the circuit, or if you, a lot of people, even though GDS Factory is open source, like you can think of GDS Factory as the engine. A lot of people don't want an engine, they want a car. If you want a car, you get GDS Factory Plus because it will help you, like, not only it has the house around the engine, so it has the user interface, and it also allows you to do schematics. It allows you to do circuit simulation, device level simulation, and it also has support. So we have also open, I think I have a slide here about it's here, kind of like what explains so the difference. So it's very similar to the Red Hat model where the Linux is free, but if you want to support it, Red Hat, you buy Red Hat. Or like there's like different parts. So there's the solvers, the plugins, and the PDKs are, some of them are open. Like for example, yours is open. It doesn't require GDS Factory Plus. But if you want us that we help you build a PDK that has simulation models, so we put a lot of work in these PDKs, but we make sure they only work in the GDS Factory Plus. And all the usability features are also, like, we spend a lot of time building like this schematic editor, so we make them only available in the Plus. So it's, yeah, it's kind of like a model. And this is basically where we were also interfacing with electronics. Traditionally, in photonics, you do the layout and the simulations, but then you need to have an analog driver to drive your photonics. And then you need to have a digital driver to drive the analog. So this co-simulation framework is something that we've been developing with another university, where we, before, the way it works is that you create a GDS factory, and then once you create like a schematic like this, you can actually turn it into a cadence simulation. But if you want to do everything within GDS Factory, even the analog part and the digital part, we are developing this with the universities so that it will be available in the future. At the moment, GDS Factory is very good for photonic, quantum, and MEMS, but we are also going to expand into analog and digital. But yeah, we will do the similar model where the core solvers are all open, and the UI usability are part of the Plus.
And I have another question. When you do the automatic routing between components, does it generate also the code so you can play with the waveguide in between, or it's just the interface?
Yeah, like for example, like here, if I move this guy, this is an electronics chip, but it doesn't really matter. It's the same thing to show. So here on the left side, we can see the schematic. So the schematic I'm seeing here in the GUI, but I can actually see the code that creates this schematic. So if and you can see, for example, this the placement of this A3. So you can see this component has an Xmin or Xmax. I can actually change the code and it will move. I don't know if you notice here, it moved. I can also put a ruler to know. Let me move it like 20 back, or just 40. So you can modify, but you can also modify the, if I modify, let me see if it's automatically router. Let me see, show. Yeah, you see. So even if I define different placement, the only thing I'm changing is I'm changing the placement of this schematic. And because the routing is defined at the schematic level, even if you define a different placement, the routing will follow. And this works for photonics, or here it's just a Manhattan route. It's very convenient, especially if you want to do something like, let me go back to the project I had before. And if you start to do things like we were doing the ring filter where I was drag and dropping, a lot of times you want to be able to define all this into the schematic. So where, like, let's say this GPT, you want to be able to also drop in a die. For example, like when I put a die, as you start putting together these kind of like, you can see like, now I have my rings and I put them inside a die frame. Let me show. Oh yeah, I want to die with paths. Otherwise, yeah, it's very hard to see. A die was just a square, so I was not seeing anything. But now I put the rings in a package, so I can actually measure it. So I have paths for the electrical routing, and then I can start routing to the paths. So yeah, it makes it very kind of like, it's very nice that you can change in text, because all these changes are actually, I can see them in Git. So I can see, for example, I changed this Mach Zehnder position and the data length. I make some new components that everything is text-based, so it's very easy to collaborate. The problem with traditional electronic flows is that people do everything with a mouse. And the way I see is that the book is more powerful than the mouse. Like the keyboard is more powerful. And it's only once you start reaching complexity, like let's say you are working, like if you look at software, how software is made, software can have a lot of complexity, and it's because it has abstraction layers. Like one person writes basically the Python code of GDS Factory, another person writes the GUI. So there's clear interfaces. I think in electronics, traditionally, the way it works is that you have a team of designers that draw the diagrams of the schematics, and they have a bigger team of people drawing wires by hand. The problem is that that's not very scalable. Like, let's say tomorrow they decide, oh no, I'm going to move my GPU like a little bit more there, and then the people need to route the wires again by hand. The way we do it here, everything is defined with code, but it's also defined in text. So easily machine learning agents can help you do that work before was sent away. So you can have faster iteration, then you can achieve large complexity.
Yeah, I have like a question that I think it will be good for as well the people from the center is if you can explain a bit more the do data for the parameterization in terms of like when you have lots of wafers or how you manage to the yield and all this stuff. I think it's useful for the audience as well. Thank you.
Yeah, I can show like a quick a summary here video. So this is all also online. So the do data provides you an interface to visualize all your chips in one place. So a lot of times in every company I was, everyone, Joaquín, where is the GDS? Oh, how do I install layout? Where do I put my data? Like this basically puts all the chips into software that you can install it on your server, and everybody in the organization can access the data and see, for example, these are like all resistant sheet structures that you can upload measurements or simulations, and then you can analyze these measurements and simulations to extract the data, the valuable data. So especially in universities or research centers where there's a lot of people coming and leaving, it's very important to be able to centralize where you store the data so nothing gets lost. So these are all the IB, and you can see some of them have shorts or open, and this will allow you to see, oh, okay, this device had a problem. And then I can take this device level and then go into a wafer level, where I can see the different wafers. And these are the die level. So first I do die, and then I do wafer. And if I look at the wafer level, you can see a wafer analysis. I can see which part of the wafer didn't work. And then you can also do lot. Like, let's say you have 3 wafers like we have here. I want to compare the different lots. How are you doing this now? Or do you have any software? Or
No, for data, no. We have like a software, internal software for just fabrication processes, but not for every group has its own like
data management.
Data management, yeah.
Is it mostly like a Drive or like Dropbox or?
It's more like the SIG internal.
Okay, I see. Yeah, so this will allow you to see, for example, like 3 wafers. What is the wafer to wafer variability? And yeah, so you can see everything in one place, and then you can see the chip as well, and you can see all the chips. So everybody in the team knows where things are, basically.
So we can fix, for example, like let's say we're depositing materials, and we're defining the process. We have 10 wafers. You stabilize the thickness that you want, and then that will give you like the variations in
correct, yeah,
all the wafers in the.
Yeah, and every wafer can have attributes. So some of these wafers, I put like doping concentration as the attribute. And let's say I want to do a doping split where I have 3 wafers, high, medium, and low doping. So you can measure the propagation loss or shear resistance for those wafers. And then you can define your upper spec and your lower spec. And once you define that, then the yield gets defined. We have another video for the specs. So I think, and everything can be done through the GUI as I'm showing here, or everything can be done through like maybe show this one, Python upload. Everything can be also done through Python. So let me see if this is the correct video. Yeah. So yeah, so I can do everything through Python. And this is just an example of how we create a layout, then we take the measurements, and then finally we go into the upload the measurements and run the analysis. So here, this one, the number 1 and number 2, I just run them all. Like it could be data that you already have. Here I'm just generating the data. And all these have video and audio if you guys want to go to the website and look at it. We made some UI improvements in the do data. So there's a new version that we're going to be releasing in the next week or 2. And the new version is going to allow you to upload any data, like even images. We have a lot of people asking us to upload SEM pictures as well. So yeah, and here I'm doing every change I make here on the right in the Python code. I can also see it real time on the left on the software.
And you were also able to, when you were pressing the wafer level,
yeah,
and when you were checking the dice, you were able to see the schematic as well.
If you have it, yes.
If
you don't have it, we can store things like schematics or DRC results. But that one, it was mostly a Python layout, so I didn't upload the schematics. So it was only layout. In the end, the schematic is important when you're doing the design. When you're doing the testing, you only care about the GDS and the list of devices under test. We call that the device manifest. So these are all the chips has devices under test, and they have test points. So I want to be able to know where do I need to probe. And this is what we store. So these are basically, so now we're doing device level analysis, and then we do die level analysis, and then wafer level analysis. And everything could be done through the UI, like clicking, but if you're gonna do like a full wafer of measurements, it's better to do it in Python. Yeah, so this one is triggering, there's a wafer with 21 dies, and every die has 3 products. So there's 63 dies. And once you have these 63 dies, I can run analysis at the wafer level. And this is the part that is going to define the spec. So you define your upper spec and your lower spec. In this case, the upper spec is 3.13, but I can increase it to 3.19, and this will change the good dies, the non-good die. And then once you define the spec, for example, for every product, I can modify the spec for 0.3, 0.5, or 0.8 spiral width. You define what's my maximum acceptance loss. And yeah, and everything will be stored there. And then I can go back to home. I load the wafers and I click analysis, and everything I did is there. So nothing gets lost. Because a lot of times it's even for yourself in 1 month from now, you don't want to be able, you want to be able to see the business intelligence. So you want to see the summary of this project.
I don't know if anyone has any more questions from the audience that are not in the room. Or in the room as well. If you have any questions, you can write them down. If not, I think we're done. So we'll wait if someone writes something. If not, I think we can close the session. So thank you. And thanks, Joaquín, for the nice talk.